I will continue with another exercise on node voltage with dependent sources. So, like for this example, we have this current source with independent sources. So obviously here you can see that Ix here, it's actually the dependent value is actually here lah, which is on V2 here. So we need to find the V1, V2 and V3 here. So we have V1, V2 and V3 here. So we also need to find the Ix here. So obviously here Ix is equal to V2 minus with 0. This is the reference node, minus with 0 over with 4. So this is your a constraint equation for this Ix. Okay, so moving on to the next for the equation that we have. So if you are referring to this circuit, you will have to see the current directions on each node for V1, V2 and V3. So from this circuit, obviously we have for V1, we have these directions and these directions, where this is leaving, which is negative, and this is entering the node positive, and this is leaving, which is negative lah. So here we can have that I, which is the summation of positive, equal to the summation of negative current lah, which is this one is entering and this one is leaving the node. Alright, so for the summation of current, we have the positive, where we have here is actually equal to 10, equal to the negative current, which is I1 plus with I2 here. So I1 plus with I2. So I1 here is equal to V1 minus V3 over 2. So V1 minus V3 over 2. We have this current directions. Okay, so we have 2 minus current and 1 plus current, which is entering 1 and leaving is 2. So okay, we go here where we have this is actually 10, and then we have this is the summation of plus equal to the summation of leaving the current. So you obviously here the summation of leaving the current is I1 equal to I2, where I1 is clearly V1 minus with V3 over 2, and then for I2 is here, which is V1 minus with V2, V1 minus with V2 over 3 here. So this is for the I1 lah. Okay, so you have this equation. So now so 10 equal to V1 minus with V3 over 2 plus with V1 minus with V3 over 3. So you need to simplify this equation. Let's say you want to kill this denominator, then you have to times it with 6. So you simplify it. When you simplify it, you will have this equation, and then you just name it as equation 1. Okay, so then okay, another thing that I forgot to say is that you have 3 nodes, so means that you need to have 3 equation lah, which is for V1, V2 and V3 lah. Okay, so at node 2, okay, here obviously at node 2 you have this entering current, and this is entering, this is leaving, so this is negative lah. Okay, so you will have I2 for this one, you will have the positive equal to negative. Okay, the positive current, which is I2 plus with 4Ix equal to the negative, which is V2 over 4 lah, V2 over 4, or this is actually Ix lah. Okay, or equal to Ix here. Okay, so obviously Ix here is actually V2 over 4. So Ix here is actually V2 over 4 lah. So you have this equation. Okay, so then obviously here is actually I2, like this one I2 plus with, when you bring this Ix here, you will have here I2 this one here going to be negative ix. So for ix minus with ix, you will have I2 plus with 3ix, and then you know that ix is actually equal to V2 over 4. Then you can just substitute the value here, ix, substitute with V2 over 4, and then you need to simplify this equation. When you simplify, you get this equation, then you name it as equation 2. And another note that we need to have the equation is actually at node 3. Okay, so at node 3, we have this as negative current, and we have the positive current, where you have this positive current is actually I1 lah. Okay, this is the positive current equal to the negative current is actually I3 here, and with the 4ix. Okay, so I1 is actually equal to V1 minus V3 over 2. So this one, V1 minus V3 over 2, and for I3 here, I3 is V3 minus 0 here, your reference node, over 6. Okay, and then you have 4ix, then you know that your ix is equal to V2 over 4. So 4ix, just substitute here with ix, and then you can simplify this equation. When you simplify, you have this, and then you name it as a 3, equation 3. So as I said before, if you have 3 equations, it's easy for you if you solve the equation to get V1, V2, V3 using the Cramer rules from the matrix. Okay, so this is the answer lah for V1, V2 and V3. So okay, I'm gonna touch a bit about these Cramer rules. Okay, for this Cramer rule, we have this, we call it as a linear equation. So this linear equation, you have like 3 equations lah. Okay, like obviously from our circuit, we have this equation lah, equation 1, equation 2, and this is equation 3. Okay, so for the Cramer rules, what you need to remember is that you need to always find the determinant for the for this value lah, in order to solve for V1, V2 and V3 lah. Okay, so first you need to convert all this value with the metric of coefficient, which is equal to m lah. Okay, so just this is actually obviously for V1, and this is for V2, and this is for V3. Okay, so for V1, so this is for equation 1, this is equation 2, and this is equation 3 lah. Okay, so for V1, for equation 1, it will be 5, -2, and 3 lah for V3. Just rearrange all this into the metric of coefficient, and then after that, you need to find each of the each of the determinant for each of the V1, V2, V3 lah. Like if you want to find for V1 here, you just substitute the value here. For B, which is your B, is obviously this value lah, which is your B. It's gonna be this value, which is your B is actually equal to 60, 0 and 0. Okay, so this is your value for B. So you need to just rearrange this one for V1, and this one for V2, and this one for V3. Just change that value lah. And then you need to find the determinant for each, and then you can find the value for, let's say this is one for V1, and this is one for V2, and this one for V3 lah. Okay, rearrange that, and then this is the solution lah, linear equation. Just convert that into your matrix, and then after that you're gonna put it as a metric of coefficient for this one, and then find the metric determinant according to the formula, this one lah. You can use this formula, and then you can find the determinant for this metric coefficient, where if you calculate, you get that this determinant is equal to 15 lah. Okay, once you get that, you need to replace this X column, which is this one for V1 and this one for V2 and this one for V3 lah. In each, you need to find the determinant for each, and then for each of these, like for this one, dx, which is 100 over 15, so then you can get 18, and this one is negative 960 over with 15, so you get negative 64, and for V3 2340 over 15, so then you can get 156 volts. All right, so this is the answer and the way how you can solve it for V1, V2, V3 if you have the three equations lah. So this Cramer rules is recommended to use when you have more than two equations lah. Okay, if you have the two equation, you can use the elimination method and the substitution methods lah. But if you have more than three equation, it's suggested for you to use this Cramer rules lah. Okay. Okay, we still in node voltage analysis, but now we're trying to look node voltage analysis with the supernode. Okay, what is the supernode actually? Okay, supernode is actually, we have two cases of supernode. The first one, if you have the voltage source connected between the reference node and non-reference node. For example, like you have this source, your voltage source, let's say this one is 10 volts, and then it's connected with your reference node. So this is your reference node. So this one is the non-reference node equal to the voltage source. So that's mean that this one, let's say here is V1, right? And then it connected with others lah. So here, the V1 here is obviously equal to 10 volts lah. Alright, so this one is also, we call it as a supernode. Okay, and for the case 2, if you have the voltage source connected between two non-reference nodes, so between two non-reference nodes means that, let's say you have these two nodes where this one is V1, V2, and then you have this source here, the voltage source. Okay, let's say here is equal to 15 volts. All right, so this is, we call it as a supernode. Okay, we call it as a supernode because we have this voltage source connected between these two nodes, so we call it as a supernode. Alright, so for this one, how you want to solve for this, you can have this equation, which is, we call it as supernode equations lah. So in order to have that equation, we need to follow this positive. Just look at this positive. So means that your current, your voltage is like this lah. It's go this way. So you need to make the equations like V1 minus with V2 equal to this 15. Okay, so V1 minus with V2 equal to 15 volts. So this is your equation for this supernode. So we have these two cases lah with supernode. So I'm going to show you the example for the first case where you have this. Obviously here you have V1 connected with the reference node with this voltage source lah. So obviously here your V1 is actually equal to 100 volts. Alright, okay, so we have this is as the first case lah, and then you only need to calculate for this V2. Okay, so means that what you have to do is you will have these equations lah. Okay, so there is a 3 essential nodes. Okay, so only one unknown nodes, because we only want to know about the V2 because we already know V1 is actually equal to hundreds lah. Here is actually equal to V1. Therefore, we only need one single node voltage in order to know what is the value for V2. Okay, obviously for that we will have, okay, just follow these current directions lah. So for this one, we know that the current directions is actually here is leaving, which is negative, negative, and this one is positive lah. So we will have the positive current equal to the negative current. So we know that the positive current is equal to 5, equal to the negative current is this way lah, V2 minus with V1 over 10 plus with V2 minus with 0 over 50. Okay, so you have this as a positive current and both of this is as a negative current. So now we can solve for that lah. Okay, like for this equation is actually it brings this 5 over here, so that's why it will be negative 5 lah. It's the same with this equation. Okay, so what you have to do is that you can just simplify this equation. For this, I think that we just need to times it with 50. So obviously you will have 250 equal to 5V2 minus with 5V1 plus with V2. Okay, so you will have 250 equal to 6V2 minus with 5V2 5V1. Okay, so you already know that your V1 is equal to 100. Okay, so 250 equal to 6V2 minus with 500. And then because you just have to substitute V1 value with 100, alright? And then you can have it here as 100 lah. So you bring this over here, you will have 750 equal to 6V2. So V2 equal to 750 over 6, and it obviously equal to this 150, this 125 lah. Okay, so that's it lah. Okay, we continue with another example for a case 2 for a supernode. So for the case 2, if you have a voltage source connected between two non-reference nodes. Okay, for this example, this is two non-reference node where we have V1 and V2, and then in between of that we have the voltage source here, right? So we call this one as a supernode. Okay, so the supernode contains of this lah 2 volts, node 1 and 2, and then this 10 resistor as well. So this one is also gone. Okay, so for the supernode case, we need to both apply the KCL and KVL lah to calculate the value for V1 and V2. Okay, so when we applying the KCL to the supernode, obviously here, okay, this is our supernode, alright? So we need to have two equations lah. Okay, two equation for this in order to find V1 and V2. Okay, one equation is from the node where the supernode happened, and also we need to have the equation for the supernode itself lah. Okay, like for this one, between this node 1 and 2 here, we will have one equation for the supernode where all of this is gone lah for the circuit, like for this example. So all of this will gone lah. Okay, then it will leave you here, just that. Alright, so that's why when you rewrite again the circuit, you will only have this lah. Okay, so what you have here, just draw your own current directions. Okay, like for this one, you just follow this. Okay, and then just follow the same rule, like the positive current equal to the negative current lah. Okay, so like for this one, we have this as entering this node, which is this one going to be positive, this one negative, negative, and negative lah. Alright, so for the positive current, we have the 2A, 2 ampere equal to the negative current, where you have the negative current is actually V1 over 2 plus with V2 over 4 plus with 7 lah, plus with 7. So this is the equation, and then you just need to simplify this equation by times it with 4. So what you have is 8 equal to 2V1 plus with V2 plus with 28, and then just rearrange this again. So then you will have 8, no, just bring this 28 here, so you will have negative 20 equal to 2v1 plus with v2. Okay, and then you also need to have the this supernode equation. Alright, you have this an equation, so just put it as equation 1 lah here. Okay, and then you need to have this between these two supernode, right? You have this v1 and v2. You can just use it the KVL, or you can just directly minus v1, just follow the directions of the positive here. So you can have the equation v2 minus this v1 equal to this 2, or you can just write it as v2 equal to v1 plus with 2. Alright, the same thing that you get when you use the KVL. Alright, so then you have all the two equations where you have this as your equation 1 and you have this as your equation 2. So now what you can do is that I think that you can just do the elimination method for this. Alright, so let's rearrange this equation. Okay, so you can have this as negative 2v1 minus with v2. Okay, we'll just bring here, right? Okay, 2v2 plus with 2v1 plus with v1 equal to 20 for this equation 1, and for this one you will have negative v1 plus with v2 equal to 2. Alright, so what you have is that you can just eliminate v2 first, right? Negative v1 plus with v2 equal to 20, and then negative v1 plus with v2 equal to 2. I think this one's gonna be positive, right? When you bring this one here, just make it negative 20 here lah. v2 plus with 2v1 minus with negative 20. Alright, so here gonna be negative 20 lah. Alright, so you can just do using the elimination method. So you can just eliminate v2 first. In order to eliminate v2, just use the minus. Okay, so negative 2v1 minus with v1, you will have negative v1, right? This one gonna be positive, right? Sorry, so this one's gonna be 3v1, again 3v1, 2v1 plus with v1, and this one is gone, equal to negative 20 minus 2, you will have negative 20 minus 2, you will have negative 22. So v1 is equal to negative 22 over 3. So this is your v1 lah. And then for v2, just substitute this value inside one of the, let's say I want to substitute in equation 2 here. So just negative v1. Negative v1 is actually equal to negative 22 over 3 plus with negative and negative, it will leave you with positive, and then this one with plus with v2 equal to 2. Okay, alright, and then just substitute the value 22 over 3 minus 2 equal with negative v2. So that's why you will have this value lah. When you solve it, you will have negative 5.33 for v1. Okay, no, for v1, for v2. Okay, so this is the answer lah for v1 and v2 when using the supernode. Okay, I think that we might have another example. Okay, for this example, obviously the equation asks you to find the value for v and I here. So you have this v, this is V, and this is I here. Okay, if you can see from this is actually the node. These two nodes is actually sharing the same voltage source here. So this one gonna be your super node lah here. Okay, this one gonna be your super node, and then you need to calculate the value for V and I. So what you're gonna do is that, so okay, so this is obviously your super node, and then you will have this as your equations lah. Alright, for this one you will have this, just put the directions lah of your current. Okay, so this is going to be one of your equation, and this one also going to be one of your equation for your supernode lah. So add a supernode in this figure A, so you will have this one is actually the positive and the rest going to be your negative lah. So this one is your positive current equal to your negative currents lah. For your positive current you will have 14 minus with, because the directions of current is like this lah. Okay, so positive 14 minus with V, we put it here as a node V here, and then we put here as a V1 lah. So 14 minus V over 4, this is for the positive current, and for the negative current, which is this one, V over 3 here, and then V1 over 2, and then one other one is V1 over 6. And then when you need to simplify in this equation by times it with, I think maybe 24, right? 24, and then when you simplify, you can have this equation as your equation 1, and another equation you will have in this for supernode. Obviously your supernode here, V1 minus with V equal to 6, so you will have V1 equal to V plus with 6. Okay, so this is your second equations lah. And then when you have all that equation, you can have do the arrangement for this both two equation to solve for V and I. Okay, and then you can just do it using the in order to find the value for V and V1 using the elimination method. And then after that you can find the value for this I. Okay, this I is actually equal to V1 over 2. V1 over 2, just substitute the value and then you can get the value for I lah. Okay, and we have another exercise for the V node, for the super node. Alright, so for this equation, obviously this is actually your super node lah, between this node 1 and node 3. Okay, so this one is node 1 and node 3. So this one you need to apply the super node, and then which is you need to apply the KVL to the loop here, to the loop, or you can have it as a V3 minus V1 equal to 30, or you can have V3 equal to V1 plus with 30 volts lah. So this is you can get the other equation. So you means that you have 3 node, so means that you need to have 3 equation including this equation for the super node lah. Okay, so okay, just have a look at this. Okay, so at this super node you will have this V1 and V3 lah. At this node V1 and V3 is involved with the all the connections which is on the V1 and V3. Okay, let's say here we have this as the negative current, here is entering which is positive, here as well as the positive, and here is the negative currents lah. Okay, so we have the summation of the positive and the negative current. Okay, so for the positive currents at node V1 and V3 here, so we have the positive current which is coming out from here, which is V2 minus with V1 over 2 plus with this one lah, V2 minus V3 over 2 equal to the negative current which is this one, V1 over 4 plus with V3 over 8. So all of this negative is actually coming from the negative current because you bring this on the other side. Okay, so that's why it tend to be negative lah. Okay, it's the same with this one. And then for this one, you need to simplify it, where you can just times it with 8. And then you found that the equation gonna be this one lah. Okay, and then you need to have another equation for this supernode. I'll show you just now, right, how to come up with this one. And you have another one which is at node V2 here, the equation, because you need to have 3 equation, right? So another equation at this supernode where is at node V1 V2, and you have another one at V2 here, right? So for this one V2, what you have is it, you can see that the current is leaving this node, which is negative, and this positive and negative lah. So you will have V2 minus V1 over 2 for the negative. So this is the negative current equal to the positive current. So this 15 is actually representing the positive current lah. Okay, so V2 minus V1 over 2, and this one is actually V2 minus V3 over 2. So you have these 3 equation, and now you can solve it for, in order to get the value for V1, V2 and V3. Okay, for this one again you can use the Kramer rules because you have 3 equations. Alright, so then after that, when you do the solution for that, so then you can get the answer as this lah. Okay, V1 equal to 30 and V2 and V3 equal to 60. Okay.